Hi everyone, thanks for coming to the webinar today. This is a webinar on best practices for managing Hadoop framework-based workloads on Amazon EMR. My name is Chad Schmutzer. I'm a solutions architect with Amazon Web Services. I focus on EC2 Spot instances. So again, thanks for coming and for spending your time with us today. Let's cover the planned learning objectives, right? So the goal of today is to help you learn how to use Amazon EZR for easy, fast, and cost-effective processing for vast amounts of data. We'd like you to come away learning how to use EC2 Spot instances and how they can significantly reduce the cost of running your EMR clusters. And we'd like you to learn how Amazon EMR instance fleets can make it easier to quickly obtain and maintain your desired capacity for your clusters. Amazon EMR instance fleets are a new feature with Amazon EMR, and it's a fantastic feature. I'm really excited about it, and I look forward to sharing it with you today. So specifically, what will we cover? So let's do a level set on Amazon EMR. So a quick introduction to Amazon EMR. Then we'll hop into Amazon EC2 Spot instances. So it's best that you have a good understanding and foundation on how Spot instances work, and that will really help you understand and learn how to couple them together with EMR. After that, we'll go ahead and walk through the console, and we'll do a provisioning of an EMR cluster using EMR instance fleets. Walk through that and give a quick example provisioning. Then we'll hop back and we'll talk a couple of minutes about a new service, AWS Glue, and understand how it can really benefit an EMR cluster config that is heavily reliant on Spot instances. And then we'll do another quick walkthrough for configuring Spark SQL to use AWS Data Glue, Glue Data Catalog as its Metastore. This is extremely simple, it's just a couple of clicks, but I still want to highlight where that can be found. So this will all take roughly 30 minutes, and then the last 10 minutes, after the 30 minutes, we'll spend about 10 minutes on some Q&A. So please don't be shy. Please put your questions in the chat room. We have some fantastic moderators answering your questions, and we're just excited that you're here with us today. So let's get started. So what is Amazon EMR, right? So Amazon EMR is essentially a managed Hadoop framework, right? So starting from the infrastructure, moving up to the data layer, the process layer, and then we get to the framework. So Hadoop sits there at the framework layer. So below it we have the processing layer, and above it we have the application layer, right? So EMR is a system that will help, as we go through this, show us how we can manage Hadoop and all of the stacks that we're showing here together. Below Hadoop, right, there you certainly don't have to only use MapReduce. We have things like Tez and Spark available to you as well. So EMR allows you to manage and run these in the processing layer as well. If we look up above the Hadoop layer, the Hadoop framework, there are plenty of other applications that can be run. Presto, HBase, Hive, Pig, Spark SQL, Spark Streaming. All of these can be managed and run and deployed on an EMR cluster, right? So again, EMR is taking the management of all of these things out of the equation, managing it for you, and helping you to run all of these in an easy manner. So below the stack, right, a couple layers down, we have the file system, right? So traditionally, there's HDFS, right, which is the file system that comes with essentially Hadoop and that MapReduce uses. EMR also introduces the concept of EMR FS, or the EMR file system, and this is a fantastic way to allow you to use a persistent data store S3 for the underlying file system for your cluster, right? So there we are. At the bottom, we have Amazon S3. Between Amazon EMRFS and S3, we have the compute capacity layered there as well. All right, so this is essentially what EMR is. This is this entire ecosystem packaged together in an easy-to-use system and format for you. All right, so why should we consider using EMR, right? There's about 6 things we'll cover here. I'll cluster some of them together for time's sake. It's extremely easy to use. You can launch a cluster in a matter of minutes. It's low cost. You pay at an hourly rate, especially when you consider using Spot instances. This is really where you can key into some extremely cost-effective EMR cluster configurations. Open source variety, right? It's using and makes available open source, a variety of open source software, also the latest versions of those softwares. It's managed, so you can spend less time monitoring your cluster and more time on getting your work done. It allows you to decouple storage and compute, right? So these things can operate independently and can be customized to meet your needs. It's also extremely flexible, so there's a lot of capabilities of customizing the cluster config itself. And so we'll get into all of these here as we move forward. So let's couple the first 3 together. It's easy to use, it's managed, and open source variety, right? So when it comes to EMR, it's managed, it's easy to use, and it's current, right? So what does this look like? From the EC2 provisioning, all the way to the cluster setup, to the Hadoop configuration itself, right? Installing of the applications, whether it's whether it's Spark, Pig, Hive, etc. All of these things will be handled by EMR. The job submissions themselves, right? So you can submit your jobs through EMR, and it will then run your job on top of this cluster in a managed fashion. And then it handles monitoring and failure as a built-in feature and service, right? So all these things are managed and extremely easy to use. So just how easy is it, right? So you can spin up a fully configured cluster in a matter of minutes, right? So this is a screenshot of the AWS Management Console. And again, we'll walk through this at the end, but just to show you how easy it is, it's with a few clicks, you can select which applications you would like to install, which software you would like to install, and the additional settings you may need. And in a matter of minutes, this entire environment, this entire stack is spun up for you and made available. It's also very easy to do through the AWS command line interface, the CLI, or the SDK with the Amazon EMR API. So a lot of flexibility, a lot of capabilities, and very easy, again, to spin up. And I just wanted to point out that the latest versions are made available as latest as we possibly can make them available through EMR for you as well. Right, so you'll notice there's a concept of EMR releases. I just wanted to highlight what that means. EMR releases are a bundling of versions of software, right? So in this case, when you see EMR 5.8.0 released in August of 2007, that means a specific version of Hadoop, a specific version of Ganglia, a specific version of HBase, etc. And so this is how we cluster releases together and then ultimately combine those to be EMR releases. So let's zoom in a little bit into an EMR release. So a release includes everything that you see here on the screen, essentially, as you select these different components, right? So there's the application stack. You can choose to use MapReduce, Test, Spark, Flink, etc. For the different types of workloads. Yarn, which is the resource management component, is managed for you. The storage, the file system, whether you're using EMRFS or HDFS or a combination, right? Things like Presto, HBase, and Phoenix. All these things are made available to you. For user interfaces, we have Hue, and then Zeppelin, the interactive notebook, Ganglia, the monitoring component. So all these things, again, are what come together to make an Amazon EMR release. Right, so what else? EMR lets you decouple storage and compute, right? So what does that mean? There are many layers of storage that you can choose from and use with Amazon EMR. In this case, we'll focus on S3, right? So let's look at this. With S3, this allows you to use EMR for different types of environments, for different types of workloads on EMR. So you could have something like a persistent cluster, maybe using Spark, SQL, or Presto. Great for interactive queries. Perhaps you have a transient cluster for batch type workloads. Maybe you need this to run so many hours a night. You want to add and remove nodes from that cluster based on the amount of work in it. And then you may have different clusters for different specific workloads. These could be different sizes, different versions. Again, all this is very easy to do when you separate your storage from your compute, right? Because you're no longer relying on specific components of the compute to provide the storage, right? You're letting your data live in S3, and therefore that allows you to manipulate the same data sets with different types of clusters without interfering with each other. And then we'll talk a little bit about this at the end, but then you can also do things like use an external Metastore for your EMR cluster to further separate compute and storage from the cluster itself, and then also allow you to get going more quickly. So another view of how you would decouple storage and compute by using S3 as your data layer, right? You definitely have the ability to use the EC2 instances for your memory store. So if you're doing things like Spark, where it's heavily reliant on system memory, but you also have intermediate storage available to you depending on how you size your cluster. There's HDFS. There's local instance store available to you on the local instances. But again, S3 should be targeted for the ultimate data storage location for your cluster. It's designed for 11 nines of durability, and it's extremely and massively scalable. So here's an example of how HBase can use S3 for a very scalable NoSQL implementation, right? So again, using EMR as the baseline framework for launching your HBase cluster. In this case, you have the concept of core nodes and task nodes, all of which are EC2 instances, but again, providing different resources and different components to your cluster. But again, HBase can use EMRFS to access the data, and that is essentially treated as the root directory for your HBase cluster and your data store. A couple of quick tips when you're using S3 for data store for EMR and just in general, right? You want to avoid key names in lexicographical order. That allows you to improve throughput and S3 list and performance, which is important. It's best to use hashing or random prefixes, or do something like reverse the date time in your data store. This helps increase throughput and also helps distribute the data across the S3 data store. If you can compress your data, that helps to minimize bandwidth from S3 to EC2. If you do are able to do that, make sure that you split it up in a compression. You have a suitable compression algorithm to split up, or each part of the file system be an optimal size to optimize the parallelization in your cluster. Using columnar file formats like Parquet that can really increase performance on reads as well. So all these are just some quick tips to keep in mind when you are thinking about using S3 as your data store. So what else? EMR also provides a very low cost. You pay by the hour, right? Just like other services, utility-based pricing model within AWS. And why is that important? If you think about it, wall clock time. If you look at a 10-hour job, if you had one instance, you can and ran a job at that instance, it could potentially take you 10 hours. What if you ran 10 instances at a time? You could get the same amount of work done, but only in 1 hour, and the cost is the same, right? So the cost of a single instance for 10 hours is the same as 10 instances for 1 hour. And again, when you couple in things like spot instances, you really can count on significant savings for your workloads. EMR also does allow you to do things like spin up transient clusters. There's no need to have clusters running full tilt 24/7, right? You can spin up clusters on the fly as you need them. Within those clusters, you can use things like reserved instances and spot instances. These are both fantastic models for saving cost on Amazon EC2 and ultimately your EMR clusters. And we'll get a bit more into spot instances here in a moment. All right, so Lastly, EMR is flexible, right? It allows you to heavily customize the cluster. So what does that mean? You can use different underlying compute capacity depending on what your workload requirements are. So if you're doing batch processing, maybe you want to focus on the general EC2 compute tier of the M3 and the M4 families. If you're heavy into compute, you need to do some machine learning. Perhaps the C3s, the C4s, the compute-focused tier of instance types is best for you. If you're doing an interactive analysis or a lot of memory-intensive workloads, maybe Spark streaming, etc., and you need high amounts of memory, we have, the X1 family, the R3 family. These are all available to you to use in EMR. And then if you're doing a heavily storage-intensive type workload where you do need large amounts of HDFS, by all means, look at using instance types such as the D2 and the I2 family. Right, so again, EMR is very customizable. So what does a typical EMR cluster look like? You have a master instance group, which consists of a single EC2 instance. You have the concept of core instance groups or core instance nodes. These are instances that contribute to the underlying HDF file system. And then you have task instance nodes and a task instance group. These are nodes that do not contribute to the HDFS file system, and your cluster can tolerate the loss of task nodes. And so we'll see why this is a great use case for Spot instances here as we move forward. So again, when we talk about EMR being flexible, it can also be tuned, and you can tune it in at least two different dimensions, for both speed and cost, right? So in this case, we're looking at running a master node, for example, on an R3 2 extra large. Depending on what your cluster needs are, if you're doing a transient or a long-running cluster, you may target different types of instances and different procurement models for those instances. So if your cluster is longer running, perhaps you want to have a heavier emphasis on reserved instances or on demand. If your cluster is a bit more transient, then you could flip that and use a larger group of Spot instances for the slave group, for the slave group or the task nodes, for example. You can even do things like use Spot instances for the master node and the core nodes and the task nodes. There's nothing wrong with that. It's just a matter of understanding what your workload requirements are and architecting for that. So you may do something like combine on-demand nodes with Spot nodes. In this example, we're combining on-demand nodes for the core nodes, and then we're using Spot nodes for the task nodes. Since Spot nodes yield up to 90% off of EC2 on-demand pricing, it's a great mixture of both availability and performance and price performance. Right. So to do this advanced Spot provisioning, we can use this new feature called EMR Instance Fleets. In this concept, we can mix and match instances with Spot and on-demand. EMR Instance Fleets will hunt down the best availability zone and find the best capacity and price for you. And it also allows you to use a feature called Spot Blocks or Defined Duration. And I'll talk about those here a bit more in a second. So I've talked a bit about Spot instances so far, so let's just jump into what Spot instances are. Spot instances are essentially a third model for consuming EC2, right? It's where you essentially bid for excess capacity. AWS has a lot of excess capacity, right? We need to be able to allow our customers to scale up in real time on demand. That means we have excess capacity sitting around. Rather than let that capacity just sit, we've enabled that in a system called the Spot market. So what are Spot instances at the end of the day? Spot instances are spare on-demand EC2 capacity with a couple of very simple rules. Right? The first rule is that the spot market is a market where the price of compute changes based on real-time supply and demand. The second rule is that you'll never pay more than what you bid. Right? So when you ask for a Spot instance, you essentially say, here's my bid price. This is what I'm willing to pay up to. If the market price ever exceeds your bid price, you'll get a 2-minute warning to wrap up your work and move on. And you'll see that EMR Instance Fleets helps you gracefully handle that potential 2-minute warning. Right, so EC2 Spot instances really yield the best capacity for the price, right? So if you can consider using Spot instances, one mechanism and thing that it unlocks is the ability to use 2 to 10 times compute capacity for the same budget, right? Otherwise, if you aren't after more compute capacity, you can consider using Spot instances to save an immediate 50 to 90% off of your existing workload. Many customers will do a combination of both, right? So I think either way, you should try this out. Give Spot instances a good hard look and understand how they can benefit you within your environment. So let's understand EC2 capacity a little bit more, right? So I've selected the Northern California AWS region here as an example. What I really want to highlight here is that that middle line there across a horizontal line dividing AZ1 and AZ2 is saying, look, each of the availability zones is a separate separate pools of physical capacity. That's kind of a no-brainer, right? They're separate hardware, they're separate data centers, but something else to understand is that actually each instance type, all right, P2, C4s, M4s are all separate pools of physical capacity. And even within each instance type, the different sizes are separate pools of physical capacity. So the physical capacity pool for a C4 extra large is different than C4 2 extra large, right? So if we start splitting all these up, every single one of these little rectangles is a separate pool of physical capacity and therefore a separate spot market. So here's another view of what this looks like. If I take the C4 instance family, for example, that's a separate spot market in itself, right? But not only that, each instance size within that, each availability zone in every single region is a separate spot market. So what does that mean? C4 2XL in availability zone US East 2A is a separate spot market from C4 2XL in US East 2B. This is just an example capture of prices here, but it does reflect the significant savings you can have off of on-demand up to 90% again, and also the point that just because the price maybe has increased in one availability zone, that doesn't mean that the price has increased in others. So if one availability zone does get too expensive, simply hunt around and look for cheaper capacity in a different availability zone. And this is something that EMR instance fleets really shines at. When you ask EMR instance fleets to spin up your cluster and you say, I would like to use Spot instances, it will hunt down and find the cheapest availability zone with the most capacity and spin your cluster up in that availability zone. So let's take a moment to understand the difference between bid price and market price. Earlier I said you never pay more than your bid price, and that's true. In this case, I'm showing the spot pricing history for a week's period of time. That's that green line. From September 12th to September 18th, the R3 4 extra large averaged roughly 18 cents per hour. There were a couple of spikes in there, but again, your bid price reflects the maximum you're willing to pay, but when it comes down to it, you really only ever pay the actual market price. So your bid price is, again, the maximum you're willing to pay. So in my humble opinion, the easiest way to enjoy the spot market, to lock in savings and reduce the likelihood of interruption, is to just keep it simple and just simply bid 100% of the on-demand price. Again, in this graph, we're showing that had we bid 75% of the on-demand price, that instance would not have been interrupted over a week's period of time. You never would have paid more than what that green line requires. Had I bid 100%, I wouldn't have paid any more than if I had bid 75%, because again, you only ever pay what the market price requires you to pay. Another best practice when it comes to spot instances would be diversification. If you can select multiple instance types, multiple availability zones, in the case of an EMR managed workload, perhaps you want to pick instances that are similar in terms of performance. So for example, if you know that large is in general yield the performance that you need, maybe diversify across C3 large, M3 large, C4 large, M4 large, R4 large, etc. I also mentioned earlier the concept of spot blocks. Spot blocks, or defined duration, are the ability to request a spot instance for a continuous period of time between 1 and 6 hours. So this is great for workloads that need to run uninterrupted for a specific period of time. Spot blocks don't yield just quite as much savings. They average roughly 50% savings off of on-demand, but that's still a significant amount of savings at the end of the day. We have a tool called the Amazon EC2 Spot Bid Advisor. This is a tool that's available online that lets you plug in variables and get a good idea and understanding of how much savings you would have potentially had over a period of time, whether it's a week or a month, and also how likely it would have been that your instance was interrupted. So in this case, the key is telling us that anything that is green or low would not have been interrupted over that period of time. So you can see an M4 extra large in this example had 0 interruptions over a month's period of time, and it yielded 91% savings over that month's period. There's also a new service called the EC2 Spot Advisor in the console. The EC2 Spot Advisor lets you plug in what type of application or workload you're planning to run on Spot. You can see here that it has map reduce job as an option. So you can plug in, how much CPU you need, how much memory you need, how many of all of that, and then the EC2 Spot Advisor will spit out a configuration with an estimated hourly price and an estimated savings over that period of time off of on-demand. So this is a great tool you can use to sort of key into what instance types you would like to use for your EMR cluster. So let's talk about a quick customer example use case. I just talked about how great EMR and Spot work together. Let's take FINRA, for example, right? They migrated their on-prem Hadoop workload onto AWS into EMR. They put their data into S3. They've got all kinds of different web applications and analytics workloads running on top of AWS. They yielded a significant savings, so they were able to scale up and lower their costs than their previous on-prem solution. And you can see a great highlight here. They're able to heavily utilize Spot instances for their EMR ETL cluster for HBase, right? So you can see here on the right-hand side, they're using Spot instances for that HBase cluster. So 60 times M3 2 extra larges, and then 1 C3 4 extra large for the management instance. All right, so let me quickly walk through what it looks like to provision an EMR cluster using EMR instance fleets. So I'm going to flip over to my AWS console. So the first thing you're going to want to do is to simply find EMR, right? So let me just search for it. There's EMR, the Managed Hadoop Framework Service. Right, we're going to click Create Cluster. I don't have any currently running. Right, so to use instance fleets, you want to click on Go to Advanced Options. Right, all right. Now that we've gone into the advanced options, we can select the EMR release. Remember earlier I talked about EMR releases and what it means. So in this case, I'm able to select EMR, the latest version 5.8.0. That's shipping with Hadoop 273, Pig 0160, and Hue 312.0, Spark 2.2.0 as well. So I can select any of these. If I don't select them, they won't be installed. Obviously, if I do, EMR will take care of installing them for me. So let's move on to the fancy things, right? On the hardware configuration page, we want to select instance fleets. So instance fleets is where we're going to be able to do this fantastic configuration of our Spot instances. First thing we will do is you can launch into either Classic or your VPC. I will select my VPC. Remember, best practice is to enable Spot to use as many subnets / availability zones as possible. So I will select 4 here in this case. Then I will head down and I'll start to configure my different node types. I can configure the master node. I can configure it to use either on-demand or Spot. Right, I can select that there. If I do select Spot, I can also determine what my maximum bid price would be. Then I can move on to configure my core and my task nodes. So one thing you'll want to do is you'll want to go into each of these and you'll want to select as many different instance types as you can for your particular workload. So in my case, I'm going to select 3 different instance types that I'm saying I'm willing to use for my core nodes. I can split up how many of the vCPUs are targeted for on-demand versus spot. In this case, I can say I need a total of 10 vCPUs as an example. I can decide whether I want to simply bid 100% of the on-demand price or I want to plug in a dollar value. If I plug in a dollar value, EMR is nice enough to show me what the current spot prices are for these particular instance types in the different AZs at the moment. So I can check that out by flipping to dollar amount and then clicking the I button, and this is sort of highlighting the cheapest areas at the moment. I can also do cool things like say, what happens if I request a number of spot instances and I don't get all of them? I can do a couple of things. I can say I can just terminate the cluster, or I can simply switch to on demand. So this is pretty cool. So I can say after 20 minutes or so of waiting for spot instances to come up, if I've set my bid price extremely low for whatever reason or some other reason that I can't procure a spot instance at the moment, EMR instance fleets will take care of flipping over to on demand after a given amount of timeout. And you can do the same thing for your task nodes. So again, keep in mind, if you are running your data set in S3 and you're able to take advantage of EMRFS, you may want to be much more heavy in the task nodes and be a heavier user of Spot and reduce the number of core nodes because you won't be needing the HDFS file system for your workload as much. So again, lastly, you can also choose to use defined duration or spot blocks. So remember the ability to request a spot instance for a 1 to 6 hour period of time. That all can be done here in the EMR Instance Fleets console. So extremely powerful. I hope this gave you a good overview of how EMR Instance Fleets can work and how they can unlock potential savings for you. So I'm going to flip back to my deck here real quick and just finish up one more item I'd like to highlight. Glue. Let's talk a little bit about AWS Glue. So AWS Glue is a new service that AWS released that is designed to manage data catalog for you with no administration, with scalable capabilities, and it integrates heavily with AWS services and also non-AWS data stores as well. So why am I talking about Glue? It's a fully managed ETL service. It automates data cataloging and preparation. There's nothing, no effort on your end to spin up Glue for you to use. So remember when I talked about decoupling storage and compute, right? So I said, hey, let's decouple your storage from your EMR cluster. But I also said let's decouple the Metastore. Let's make the Metastore external, right? So where can we put that? One option would be to use Glue. So using EMR, even natively within the console or the CLI, you can tell EMR to use AWS Glue catalog as the external data store for your metadata for your Hive or your Spark SQL EMR cluster. So that's a very easy thing to do. So if we sort of put it all together, we've got our sample data lake pipeline that we're talking here, right? We're talking about putting our data into S3. We're talking about using EMR and then putting the data back to S3 when we're finished. Providing a huge ecosystem for running our S3 data lake on top of AWS. So I said it was super easy to use Glue as a data catalog for a Spark SQL Metastore. Let me show you what that means. I'm going to go back to the AWS console. I'm just going to go back here a couple of clicks. All right, here it is. So if you select either Hive or Spark or Zeppelin, I believe, this box here for use for Spark table metadata for AWS Glue catalog, you just simply select this and you're on your way to using AWS Glue, right? So again, when you're talking about using Spot instances, when you're talking about using EMR, you want to persist your data both on S3 and also persist your table metadata outside of the cluster. Glue is a great option for that. So if you're running a transient workload that's going to be coming up and coming down, using Glue with Spot instances and S3 is really the best of all worlds, if you will, for both performance and for price and for flexibility. All right, so I'm out of time. I just wanted to say thank you so much for attending this webinar. We will reserve the remaining 5 to 10 minutes for some Q&A. Again, thanks for coming. This deck will be made available online after the fact. Thanks for coming, everyone. Have a wonderful afternoon or morning.